Assalamualaikum warahmatullahi wabarakatuh. My name is Fathia Ainina Jasmine. For optimizing a hydrogen tank, I will use or combining the concepts of the A5 problem solutions for designing a hydrogen tank. First, I have to understand the problem. So this is use consciousness and initial thinking. I am tasked with designing a hydrogen tank that can store 8 liters of hydrogen. And then I need to maintain focus on this goal throughout the design process. And then I will gather information about hydrogen storage tanks, including materials, shapes, and safety consideration. And then the next step is intention. My intention is to design a safe, efficient, and a functional hydrogen tank with a capacity of 8 liters. And then this tank design could be used for various applications, and ideally it should be scalable for different capacities. And then the next is initial thinking is the same as the last one. So I will gather the information about the hydrogen storage tanks. And then the next step is idealization. So I will break down the problem. So I can consider a cylindrical tank shape as it's a common and efficient design for hydrogen storage. And then to minimize material usage and weight, I will optimize the tank's radius and height. This might involve using mathematical formulas or optimization techniques. For this one, I will show you the optimization techniques. Then the last one is instruction. So I will show you the code for solve this problem. And the result is optimal radius, optimal height, and minimum surface area. So this is the presentation, the PPT of optimization. So in this PPT, I will tell you about the definition of optimization, strategies for maximizing hydrogen storage efficiency, and designing an 8-liter hydrogen tank. So what is optimization? Optimization is the process of finding the best possible solution to a problem, considering a set of constraints. It involves maximizing or minimizing a specific objective function while adhering to limitations or restrictions. So the breakdown is objective function. This is define what you want to optimize. And then constraints. These are limitations or restrictions that your solution must satisfy. Variables. These are the elements you can adjust to influence the objective function. And then feasible solution, a solution that meets all the constraints of the problem. The last one is optimal solution, the feasible solution that achieves the best possible value for the objective function. The strategies for maximizing hydrogen storage efficiency. First one is enhanced storage density. So they are compressed hydrogen storage, employ high pressure tanks to store hydrogen in its gaseous form. And then cryogenic hydrogen storage, liquefy hydrogen at extremely low temperatures, achieving higher energy density but requiring complex refrigeration systems. And then solid-state hydrogen storage, store hydrogen in solid materials like metal hydrides or carbon nanotubes. And then the last, chemical hydrogen storage, utilize chemical compounds like ammonia or methanol to store hydrogen. Number 2, optimize storage materials. Develop advanced materials. Explore the materials with enhanced hydrogen absorption capacity, gravimetric capacity, and cycling stability. And then tailor material properties. Engineer material properties like pore size, surface area, and chemical composition to optimize the hydrogen adsorption and desorption kinetics. Then investigate composite materials. Number three, advanced storage system design. Optimize tank design, enhance heat management, and develop integrated system. Number four, leverage advancements in hydrogen production and utilization technologies, coupling with renewable energy sources, optimizing fuel cell and electrolyzer technologies, developing advanced hydrogen distribution infrastructure. Number five, pursue regulatory and policy support, like advocate for supportive policies, promote harmonized standards, and raise public awareness, so on and so forth. So this is the example of optimization. Uh, Correct me if I'm wrong, but I think this is the right one for the example. So the question is designing an 8-liter hydrogen tank. So the specific is determining hydrogen tank dimensions. So for this question, I used Python for solve the problem, and then I get the result. For the optimal radius, I use the centimeter. For optimal height and minimum surface area. Thank you so much.